Hi Dhwani, what are you doing in school, Dhwani?
Um, we're doing we just finished the cosecant, cotangent, and secant graphs, and we did like the tangent graphs already.
Oh, you did inverse trigonometric functions?
Yeah. I mean not inverse, just reciprocal.
Okay. That's good. That's good. Okay, so for today, right? I plan to do tangent. I don't know. We can do if you want to do. We can do this cotangent, secant, cot functions. But I'm going to concentrate more on inverse trig functions. Okay, so let's go ahead. Did you have any questions from your school or whatever? Do you have any questions to discuss? Do you have any questions? 1 minute, guys. 1 minute. Sorry, guys. I'm back. So, okay, let's go ahead and review a little bit on the tangent functions, and then we'll move on. Do you have any questions, Dhwani or Lopa or Krish or Shragvi? Any questions you have?
No.
Okay. And before I start, right, can we do a 1.5 hour class, meaning 1 hour 45 minutes class next week and the next week, guys? Can we
Uh,
do that? We can extend the class. Does that do good?
Miss Priya,
Yeah, ma.
I have a question regarding the reciprocal graphs.
Which one, ma? Regarding what?
The reciprocal graphs, like the cosecant, secant, cotangent.
Sure, we can discuss that. You
Like
shall we? Mm-hmm.
if it shows you like a transformed equation, I keep messing up on how to like find the like transformed period, asymptotes, domain, and range. Like when it's like a transformed equation, like for example, like it's like 5 cosecant parentheses like pi minus 2x minus 1, like when it's transformed and like you have to figure out the characteristics like the
I
domain, range, and period.
I
I keep
I
messing up
hear
on
you.
because like I don't know what number affects what part of the graph. Like if does it like does the vertical that like what does each part kind of affect?
I see. We can do that, ma. We'll do that.
Okay.
Make sense? Yeah. We'll definitely do that. Or at the end, wait, ma. I will help explain that and then let you go. Does that make sense?
Yeah.
Okay. So for a transformed cosecant secant, you're saying, right? Will do, ma.
Yeah.
First, let's go ahead and discuss. Okay, we started with tangent. If I'm right, we started with tangent, right? Last week. Let me go there first. Let's see. Inverse will go later, but before that, I want to do tangent. Okay, so let's see. Okay, let's go back to a unit circle. What happens in a unit circle? Let's see. Yeah, this is what I wanted to bring up. We will. Are you all able to see my board? Krish, you're able to see?
Yeah.
Manav, you're able to see. Okay. Manav, what are you doing in school, Manav?
We're doing the graphs of secant or graphs of all trig functions.
Inverse is done?
No.
Okay. So slow, see here. Okay. Think about, okay. So here, this is cos, comma, sine, right? Cos, comma, sine, right? So how a tangent graph evolves? This is just a review of what we did last week. I just started with it, but then didn't get to do it. So tan will be sine by cos, right? So when you think about it, so tan starts at 0, but then it goes on increasing. When you think about it, it goes on increasing. Tan 45 will be a 1. That's right smack in between. This point is so important. That's why I'm saying that. Tan 0 will be a 0. But then tan 45 root 2 by 2, root 2 by 2, right? So there it will be a 1. But then at 90, see what happens. 1 by 0, it becomes undefined. See, so when you start at 0, it becomes undefined at pi by 2. So when I graph this, right, pi by 2, let's say minus pi by 2. So see here, it starts at 0. At 0, it starts at 0. However, when you think about the minus pi by 2, here as well cos comma sine, right? So sine by cos is undefined here. So at minus pi by 2, it goes to undefined. So that becomes an asymptote. Okay. Pi by 2 also becomes an asymptote. It goes to infinity. And does that make sense? So here, slope starts at 0, gets larger as it approaches infinity. At 0 equal to, gets larger until it approaches infinity. At theta equal to pi by 2. At pi by 2, what happens? The slope becomes undefined. Any questions still here? Then the slope is very negative, but starts to grow towards 0. See, then the slope becomes very negative. See, after pi by 2, see what happens? This quadrant has what negative? X coordinate negative, right? Minus root 2 by 2, root 2 by 2. So right smack at that 45-degree angle from here, right? Again, it goes to a minus 1, right? So that's what is in here. Again, it starts here and then goes here. Then there is another asymptote at pi by 2 plus pi. You see the distance between these two is pi, right? So that becomes the period. Now again pi, this will be pi by 2 plus pi. Again there is another asymptote. Now thank you.
Tan 45 1 by root 2 cos 45 tan 45.
Yeah. Once we reach an angle, see here. So can you guess this, guys? Once we reach an angle of what, we are back to slope 0 again. Then the slope is very negative. We go to the very negative slope. And then when it reaches the angle of, you want to say, guys, I want you to be interactive.
Pi?
Pi, good job. Pi, we are going back to a slope of 0 again. As soon as we pass the angle pi, the slope will be the, see, once it passes, see, this is exactly the same as this, meaning this repeats itself here. So as soon as we pass the angle pi, the slope will be the same as it was in 0 to pi. Every dash revolution of the circle, the tangent function, every half revolution of the circle. Make sense, guys? So what is the period of a tangent function? What is the period of a tangent function? What is the period of a tangent function?
Pi.
Pi. Manav, Dwani, you both are not on the video.
I have to eat right now.
Okay, ma. Video gives accountability. That's why I keep bugging you. Even for me, for that matter. Let's see. Now, I really want you to be able to plot this. Let's see. One transform function I'll do, ma. So, let's see this graph of a tangent function. I'll take this graph. I'll just show you the graph and then I want you to know where the asymptotes come because that's quite important. Okay, when you look at this graph, right? So pi by 2, because at these it becomes infinity, right? In the unit circle, at these points, right? This point, right? It becomes, this is 0, 1, right? So sine by cos becomes undefined at this point and this point. So minus pi by 2 and pi by 2, you have asymptotes. Here, this goes like this. You know what? But the way I have done it is, I really want you to show at least one point in any tangent graph you draw. So when you think about it, right smack in the middle, that's why I'm saying the middle is quite important. Right smack in the middle, right? It's always equal to 1. So let's plot that point anytime you put the tangent graph. Make sense? So it goes like this. Any questions? Any questions? Okay. So that's on tangent, but then I really want you to be able to plot. Okay, now coming to the vertical asymptotes, right? Okay, let's see. Coming to the vertical asymptotes, you know that the vertical asymptotes occur at x equal to pi by 2, correct? Now you're going to help me fill this in. Okay, if you fill this in, you have understood it. Now, for the graph from tan b theta, for tan theta, you know the asymptotes are at minus pi by 2 and pi by 2. That we know, and these are points on the graph. Now, can you help me fill this in? For the graph of tan b theta, what is the period?
Hi.
Tan theta, the period is pi. Tan b theta,
Pi by b.
pi by b. Okay. Now, a vertical asymptotes, okay, pi by b, right? Vertical asymptotes, so for the same tan b theta is what we are considering here. For that, the asymptotes occur at pi by b, first at pi by b, and then since the period is pi, right? So it keeps on occurring at plus k pi by b. Make sense? Makes sense, like here, right? For asymptotes, how does it occur now? Where does the asymptote occur? Pi by 2 plus pi. Period is pi, so it becomes 3 pi by 2, the next asymptote. Then the next asymptote will occur at 3 pi by 2 plus pi. What happens? 5 pi by 2. Makes sense, guys? Okay. If you didn't get it, you have to let me know, please. Now, okay, I want to do one transform graph and then move on. Let's see. I really want to do one, at least the asymptotes. Tan 2 theta by 3. Tan 2 theta by 3. I'll be a little fast today. Tan 2 theta by 3, because I intend to cover this one. Can we try this one? Tan 2 theta by 3. Here, for this function, I would really like to tell me where will be the asymptotes. First, the vertical asymptote. The first vertical asymptote will occur where? And then after, in terms of k. Remember, we just now learned, right? Tan b theta. So, the first vertical asymptote will occur where? Just send it to me. We'll see where we are. Can we try? We'll also plot one more function. Let's see. Tan 2, I just want to know where will be the first, after 0, where will be the first vertical asymptote for this function. And how does, okay, at what interval? Meaning we studied here, right? The period is pi by b, then pi by b plus k pi by b, right? Here, basically, what is the b value? B value is 2 by 3. So tell me where will be the first vertical asymptote, and all asymptotes will be at what line? General equation I want. So like this. You can send it to me in chat, please. நான் பண்ணுறேன் விடுங்க விடுங்களேன்ப்பா அப்புறம் பண்ணுறேன். You want to try that, guys? If you get it, I'll move on. Yes. Yes, Ragvi. The general asymptote. Okay, let's see. 3 pi by. Okay, Parvini.
I'm sorry.
Let's see.
I meant 3
Some,
pi by 2.
something feels wrong, right, Amma? Huh?
I flipped it. I meant 3 pi by 2.
Yeah, that's what I feel too. Do you want to resend?
Yeah.
Okay, so if it's going to be pi by b, right? If you're getting confused, write this division. I always get confused. I write it this division. So that way, when I multiply, it becomes c. Make sense? Lopa, I want your answer, Lopa. Manav, are you doing Manav?
I'm trying to solve this.
You you kind of?
I'm trying to solve this. I think I slightly forgot this.
Oh, no problem. See, I'm just asking you where will be the vertical asymptotes.
Wait, can I say the answer?
Yeah. Shout out. It's fine.
Is it every 3 pi by 2?
It's not. It's not every 3 pi by 2, right? 3 pi by 4, right, Amma? Dhoni, you want to explain that?
Is it wrong? Is my
No,
answer
no,
wrong?
that is right. You want to explain that?
Yeah, I can. What I just did was I took what was inside the parentheses, which was like 2 or 3, and I just solved for x. 2/3 x equals pi over 2 plus pi k, which is like the original tangent equation, and then I just solved for x.
Okay. Let me write down. Go ahead once more. How did you solve? So
So I
period.
just did
Uh-huh.
2/3x or theta,
Two.
or it's the same thing, equals pi over 2 plus pi k, and I just solved for theta.
Good job. Okay. First, let's go to this pi k. Okay, so basically, okay, we'll do your way. I was okay. So see here. Usually in a tangent function, the asymptotes occur at minus pi by 2 and pi by 2. Correct. Now here there is a 2 by 3 horizontal. When you think about it, this is a 3 by 2 horizontal dilation. Correct. So let me get this out. I'll do it from the start. Here
Oh, you can just
b.
equate it to pi by 2 or like 3 pi by 2?
Yes, you can equate it to pi by 2. So basically, usually your asymptotes is at pi by 2 minus pi by 2, right? What is the period in here? Here, what is the period
Is
in
it
here?
3 pi by 2?
3 pi, 3.
Wait,
Lemma, what is the period in there?
I
Period is pi
think,
by b. Period is pi by b, right?
yes, it's pi by
Pi
2
by
by
b,
3.
right? Yeah. Let me put it. Pi by b. So pi by b is 2 by 3. So that will be 3 pi by 2. Any questions still here? So this is pi by b. Now pi by this one is the vertical asymptotes, right? Occur at pi by 2b plus k pi by b. Why? Because now the first occurs at pi by 2, right? So what we can do, 1 by period, period will be equal to, so here let's go ahead and substitute this. Just that my way of telling you was this one, so I'm going to go ahead and substitute here. Theta will be equal to pi by 2 times 2 by 3 plus k pi by b. What happens here? Theta will be equal to 3 pi by 4 plus 3 pi by 2k. So the first asymptote will happen at 3 pi by 4. Then the corresponding asymptote, here the period is 3 pi by 2, right? So 3 pi by 2 gets added to this 3 pi by 4. So the first asymptote after 0, right? If the same graph is given, the first asymptote will happen here. The first asymptote happens at 3 pi by 4. This is 3 pi by 2, right? Right smack between this 1, 2, 3, 4, 5, 6. So the first asymptote will happen here. 3 pi by 4. Again, you keep on adding 3 pi by 2, 3 pi by 2, 3 pi by 2. When you keep on adding that, then you get the other asymptotes. Any questions here? Any questions here? Any questions?
No.
Shragvi, you're getting it?
Yeah, I get it. I got that in two.
Okay, I didn't see, ma. The latest ones I didn't see. Okay. Advik, did you get it?
Yeah.
Okay. So now let's keep moving on. Okay, I really want you to be able to plot this one. Vertical asymptote, if we are able to understand. So first you calculate the period and then you get the vertical asymptote. Let's see. Let's see this one. I really want you to be able to graph this. Let's see this one. I'll graph it otherwise, but I want you to try, please. Okay, I'm going to erase this off. Can we try this one, guys? How do you plot this? I want to go to inverse trigonometric function immediately and then I'll move on to whatever functions you need. So here, can we plot this? Can you plot and show me what I want to know here? I want to know, would you be able to plot this graph? Okay, first let's calculate the period. What is the period here? What is the period here?
Is it two? You're on mute.
Go ahead.
Is the period two?
Is it 2 pi?
Yeah, a period is 2 pi. Good job. Good job. Go ahead. I can help if you need. Please tell me, guys. Just 1 second, guys. Sorry, guys. Then what? What is the vertical asymptote, Amma? Where is the vertical asymptote? Okay, period is 2 pi. How did we discover that? Let's see. Advik, did you get the period? Okay, first let's... Advik, did you get how to find the period? Shri, did you get how to find the period?
Yeah.
See, I would rewrite this function as, first of all, I need to take out whatever is common. Then only I'll be able to plot the graph. Minus 3 tan, I'll take out the half. When I take out the half, it becomes theta plus pi minus 2. Any questions here, first of all? Any questions on this? Okay. Now, let's see. What is the amplitude? First let's tell what are the transformations. This is a reflection on what? This is a reflection on Krish, this is a reflection on
The x-axis.
Amma. This one is a reflection on y will be
Oh,
equal
y-axis, sorry.
y. This no, you're right.
X.
This was a
Okay.
reflection on
Wait, Miss
x-axis,
Priya,
Amma. Yeah, Amma.
does the vertical asymptote repeat like every period?
Yes,
Okay. So
perfect.
if there's
That's
a
right.
vertical asymptote at like pi by 3, the next, and the period is like pi, the next one is at 4 pi by 3.
F- Where is the first vertical asymptote?
If it's at pi by 3, it's not related to this one.
Okay, go ahead. The first asymptote is at
Pi by 3 with the next, and the period is pi, would the next asymptote be?
Amma, 1 minute, Manav. I need to write down. Tell me what was your values. First vertical asymptote at
Pi by 3
pi by 3 period
is pi.
pi. Then what
The
happens? The
next
second
one be 4 pi by 3.
correct. That's right.
Okay.
And the next one would be 4 pi by 3 plus pi because tangent curves have a period of pi. Make sense?
Yeah.
Yep. These are the vertical asymptotes. When you go backward, right? Then when you go backward, let's say you start at pi by 3. If you want to go backward on the negative axis, then you subtract pi. Make sense?
Yeah.
So that would be minus 2 pi by 3. So these would be the vertical asymptotes. Make sense?
Yeah.
Okay. Whatever you have gaps, fill it in here. If you don't know, learn the basics in here and then reiterate in school. That way you will have a solid foundation. Now, amplitude is 3. There is a reflection. And then what is this? There's a horizontal stretch by 2. And then what is that? It's the same transformation what you learned in algebra 2. This is phase shift right or left? Phase shift right or left?
Left.
Shift left by pi and then what is this? Down by 2. Right? Yeah, see there's a lot of things going on here. So I really want a big graph. I'll do only one. We'll do it properly, ma. Only one graph we'll do. I want a nice graph to plot. Hold on. Let me see. This is a nice one. Let me take this graph. It's a bigger graph I want to show. Okay, I'm going to plot it in here, okay? So, let's see how to plot it. 2 pi, correct ma. Manav, that's right. Let's move on. Okay, now we know what is the period here. B, what is the B value? B value is half, right? So pi by B, right? Period. Pi by half is 2 pi. So basically the period is going to be 2 pi. So I'm going to graph and show you. I'll stop only with one, okay, after that. But there is a reflection on the x-axis. So that's going to entirely change the graph, right? So let's go ahead with this. Let's see. If the okay, first of all, there is a shift of pi as well. There is a shift to the left by pi. Okay. So your usual graphs will be like this, right? I'm going to show it like this. This is the parent graph. The blue one is the parent graph. Now, what is going on here? First of all, shift left by pi. If this is shifted left by pi, right? What happens to the graph? So our earlier graph, right, is going to be like this, a tan graph, right? But here there's a lot of changes. Now, the amplitude, considering this as 1, the amplitude becomes 3, okay? Then there is a horizontal shift by 2. Horizontal stretch by 2. Then shift left by pi, down by 2. You guys want to do or you want me to do? Please let me know, guys. I'm okay with anything. What happens at 0? What happens at 0? If you substitute theta equal to 0, what happens?
0 undefined.
0 is undefined. Good job. So that's an asymptote. Nice. So I'm going to change to red for you to know. 0 becomes an asymptote. And then 2 pi is the period, right? Here again, 2 pi is your period. Now what happens? Right smack between that, right? Here. But it's going to shift down by 2. But guys, the problem here is there is a reflection on the x-axis. So your usual graph went from down to up, but this graph is going to go from up to down. Meaning starting at 0 it's going to go from up to down. So that is this reflection covered. And the amplitude is 3. The amplitude is 3 right smack in between. See, pi it has to cross through 0. So right smack in between, I'll put it at 3. Does that make sense, guys? Does that make sense? Right smack in between these two, right? I'll put it at 3. But guys, one thing what you need to know is it is shifted down as well. So let me include that. I didn't shift down, so I'm going to include that now. Okay, let's do. I'm going to first shift down. Shift down by 2, right? So basically this is my 0 point. Minus 1, minus 2. So here, right, this is going to shift down. But then 3 amplitude means right smack between these 2 points, I can go 3 up. 1, 2, 3. You see here, right smack in between. 1, 2, 3. Does that make sense? Guys, does it make sense? Hey, does it make sense or not, guys?
Yes.
Okay. Can we move on? Dwani, Advik, Parvini, Manav. Yeah, I need some concurrence.
Yeah.
Shall we move on? Okay. Okay, and one more function I'll give you, but I just want you to tell me the period. That's enough. Half tan 2 theta minus pi by 2 plus 1. Half, let's go ahead and do that. Half tan 2 theta minus pi by 2 plus 1. How about this, guys? Tell me, first of all, rewrite the function. Common has to come out. Okay, phase shift needs to be clear. Common has to come out means when you look at it, this is so messy. I want only theta. What to take out as common? I'll rewrite the function as what? To take it out as common, theta minus pi by 4 plus 1. Correct, guys? Now, what is the period in this function? Can you tell me? Not a hard one, right?
In chat or
Yeah, you can shout out, ma. I just want.
what?
What, ma?
Pi by 2.
What?
Yeah, pi by 2 is the period. So the first vertical asymptote will occur at where? Pi by 2 is the period, correct.
First one is at 0.
Yes, first one is at 0. Great. And after 0, the first one occurs at
Pi by 2.
Yup. Pi by 2 amma. Period is pi by 2, right ma now? Let me write it down.
I just added the period to the asymptote.
Oh, okay. Period is pi by 2. Okay.
Yeah.
Why? Because usually it's pi by b, right? B value is 2, so period is pi by 2. That's great. Okay. Now the first vertical asymptote occurs at where? Pi by 2b plus k pi. Basically the first one occurs at pi by 2b. And after that it's k pi by b. Now b you know is 2. So the first vertical asymptote occurs at pi by 4. Now after that, yeah. So after that it happens at k. You will have to add k pi by b, k pi by b, k pi by b. Substitute k equal to 1, b equal to 2. So what gets added? The next asymptote occurs at pi by 4 plus pi by
Wait, it's
2.
10 0, but 10 0 isn't undefined, right?
Tan 0?
No, 10 0 isn't undefined, so how is it
No,
inverted
tan.
class?
Yeah, tan 0 is not undefined. However, there is a phase shift here, right? The phase shift moves the asymptote. Does that make sense?
If it's, is it the 2 times pi by 4?
இது மாட்டும். Mana, what? Repeat your question.
I'm not
Repeat
sure.
your.
Could you go over the vertical asymptote again?
Vertical. Okay. The vertical asymptote. See, for a tan graph, the period is pi by b, right?
Yeah.
Now, vertical suppose if it is tan b theta, right? It is pi by b, the period, right? And the vertical asymptote, we take it as pi by 2b plus pi k by b. Here,
Oh,
substituting this as 2, what happens? Pi by 4 is your first asymptote, and then you keep on adding. What is the period in this graph? You keep on adding that pi by 2, pi by 2. Remember, this was pi by 2, the period, right? So the first asymptote happens at pi by 2b. But after that, you keep on adding this pi by 2. This is actually pi by 2. So keep on adding that pi by 2, pi by 2, pi by 2. You will get the asymptotes. Does that make sense?
yeah.
Okay. Now, for finding 0, usually what I do, I put theta equal to 0. Okay. When theta equal to 0, what happens here? That becomes half tan minus pi by 2 plus 1. What is tan minus pi by 2? What is tan minus pi by 2?
Undefined.
Undefined. So basically, you see here, if I substituted theta equal to 0, the entire value became undefined. So 0 was an asymptote. Make sense? Did it make sense?
Yeah.
Okay. So basically, oh, what was the question, Asma? Sorry, I think I got it off. Question was like half tan 2 theta minus pi by 2 plus 1. Half tan 2 theta minus pi by 2 plus 1, right? So basically this is 0. Here I rewrite this function. I cannot use this function as it is. Take 2 as common, minus pi by 4 plus 1. Now b equal to 2, a equal to half. Any questions, guys? Amplitude is half. So what I'll do is, I'll quickly do this. First vertical asymptote. Period, what did we calculate? Pi by 2. First vertical asymptote happened at pi by 2b, right? Pi by 2b means 2 pi by 2b. Pi by 4. So pi by 4 plus pi by 2 is what? Pi by
3 pi by 4.
pi by 4. Pi by 4. So let me get you the graph directly. So the period is pi by 2, vertical asymptote at x equal to pi by 4. Does that make sense?
Yeah.
Okay. Now let's go to, I'm going to discuss inverse tangent function, inverse trig functions first, and then let's move on. Okay, so when we get this done, oh my god, give me a minute, guys. Okay, now I really want to finish inverse tangent function, go to the cot function graphs. Let's see how much is possible. Okay, guys, give me a minute. Okay, now how about this? See, okay, I'm going to take this. That way, for me, explanation becomes easier. Okay, let's do this one. Have you discussed okay, so coming to, maybe you have not discussed this in school, but I'm going to take this first, inverse trig functions. I'll go by the order, the sequence given by college board, right? The benchmarks. So we will discuss cot after this. Cot, cosecant and secant functions after this. Shri, are you listening? Okay. Now
Yep.
I have shown you the sine graph, right? Domain is all reals. What is the range? What is the range of this function?
-1 to 1.
Negative 1 less than or equal to y is less than or equal to 1. The graph is in here, great. Okay. Now, what is this inverse trig functions? Can I see? It is an inverse function, you all know. So, can we fill up the domain and range quick? -1 is less than or equal to x is less than or equal to 1. Are you all with me?
Yeah.
Okay, now plotting is very easy, guys, provided you understand this. Here, x, is it x and y? Okay, I'll take it as x and y. So let me go ahead with minus pi by 2. I'm going to just take three values, minus pi by 2, 0, pi by 2. Okay, what are the values in here? Minus pi by 2 is a -1, 0 is a 0, pi by 2 is a 1. Any questions still here? Okay, see, inverse means you're going to switch. Okay, please, if you understand this, you don't need to confuse or feel inverse trig is hard. I'm just going to shift this blindly. You can do this. Make sense? Does this make sense till here? Krish, did it make sense?
Yeah.
Okay, the plotting is going to be a little tricky. That's why I keep telling. Here, see here. Here, see, the thing is, sorry guys, give me a minute. Okay, let's move on. So on the x-axis, you had minus pi by 2, 0, pi by 2, right? But now we changed it to 1, 0, minus 1, right? So I'm going to put this on the x-axis, and on the y-axis, I'm going to put it as pi by 2 and minus pi by 2. Now guys, the thing about this graph is, we are going to continue graphing this. Let's see. -1 is a minus pi by 2. -1 is a minus pi by 2. 0 is a 0. And then 1 is a pi by 2. Any questions here? Any questions?
No.
Okay. Now, I don't want to just show you the 3. Okay. I'll tell you why we only are bothered about the 3. I don't want to consider just the 3. I'm going to move a little bit further, minus pi, and then I'm going to also add in pi. Let's see. Okay, so at minus pi, it's a 0, and at pi, what happens? It's again a 0. Any questions till here? Now, I'm going to add those two here, 0 minus pi and 0 pi. Now, I'm going to put this. You see, this becomes a point here. This becomes a point here. Any questions still here? So, the graph gets shifted like this. Any questions? Okay. But now, I included more points, pi, minus pi and pi. So, the inverse is not a function, right? I cannot take this further with this, meaning the inverse, this is the inverse, sine inverse of x graph. Okay, but it's no longer a function, right? So, I need to make this as a function by restricting it to some domain. What do I do for that? What is the domain I can restrict it to so that it becomes a function? It should pass the vertical line test, remember, for it to be a function. So, what domain restriction I can give to this graph? What domain restriction I can give to this graph to make it a function? Guys, you have to be interactive. Advik, you can tell me. It's not a function. It is not passing the vertical line test, right? How do I make it? What domain restriction I can restrict it to?
So that it passes the vertical line test?
Yep.
Oh, -1, 1.
Yep. So that I delete this off. I have to restrict the domain. In the inverse function, I have to restrict the domain to -1 to 1. Okay, if I do that, the range will become what? The range will become minus pi by 2 to minus pi by 2. Makes sense? So the graph for the sine inverse of x becomes, this is 1, this is minus 1, and I'm going to restrict it. This is pi by 2, this is minus pi by 2. So basically, this was this, this was this, this was this, right? So this is my graph. Any questions, guys? Any questions? Any questions? Guys, any questions?
No.
Wait, Miss Priya,
Ma?
how would it like not curve back? Cause it's still within the domain, right?
Give me a minute, ma. It's a little noisy in here. I will do the needful. Give me a Sorry, guys. Okay, now it's no longer noisy. So this way, this is good. What is your question, ma Parvini?
So you know how it curves back to 0 on both sides? How would it like not do that? Because it's still
Where am I?
on the
You have to
domain.
clearly explain. I don't get it.
When it wasn't passing the vertical line test, it went back from 1 to 0 and -1 to 0. The part where you
Correct.
crossed out. How would it not go back because of the domain? Like, I don't get it.
You don't. Okay. Well, how we are restricting the domain is what you're not getting it, right?
Yeah.
Okay. So if you understand this, everything becomes easy, guys. Inverse strict functions become easy. So here you had it like this, right? This was 1, this was -1, then pi was a 0, 0. So basically this was in here, there was 1 point here, there was 1 point here. When you think about this function, oh my god. Okay, when you think about the, one second. Okay, so it was like this, right, Parvini? Now when you draw a vertical line test, right, see, it will again, see how many points are being cut, right, ma Parvini? It is cutting these 2 points, right? Now I don't want that to happen. How can I not make that happen? The only way is to cut down whenever the second point comes. So basically after this point, this is a repeat of this, right, ma? This is a repeat of this, right?
Yeah.
So take this out, take this out, then you'll have unique values, right, till here.
Yeah.
So what is your question on this?
I don't get how you take it out.
Take it out in the sense you are restricting the domain to -1. You are restricting the domain to -1 and 1. I'm not.
But
How
it's still
do I?
within that domain. That's why I'm asking.
Yeah. I see what you're saying. We are restricting. Yeah, we are restricting the domain. Wait. Are we? Wait a minute. Where is my graph? Okay. So in this graph, you know what mistake we did here? Okay, pi by 2, pi by 2. You're restricting it to. Okay, hold on. I'll tell you what we are here. Okay. We are restricting the domain in the original function. When you look at it, we are restricting the domain in the original function. This is what we did for quadratic equation too, right, Parvini? Minus pi by 2 is, I understand what is your question. You see, is this okay? You're restricting the domain of the original function from minus pi by 2 to pi by 2. You see what I mean? Then your range in your transformed function gets restricted to your range gets restricted to minus pi by 2 to pi by 2. Does that make sense, Parvini?
Yeah.
Okay, for that matter, right, your quadratic function, right? Your quadratic function, when you found out the inverse, right, it was a function like this. It was not even a function. So what did we do? We deleted this off, right? There, the domain was restricted, yes, but I didn't mean that the inverse function's domain was restricted. The original function's domain was restricted to only this. Which side did we take it off? We took off this negative side, remember?
Yeah.
So the domain of the original function was removed. The domain of the original function was restricted from 0 to this side, correct?
Oh, yeah.
So the range of the transformed function was restricted. Same thing happens here. The domain was all reals, correct, ma?
Yeah.
So we deleted this, and when we transformed, this no longer existed. Only the 3 we will plot. Does that make sense?
Yeah, I understand now.
Okay, that is why I really wanted to differentiate with the 3. Why we are only keeping the 3? In your original function, you want to restrict some x values, only the 3x value, not the 3, just that interval. So that way, when we switch, right, in the transform function, the range gets restricted basically. Domain we already wrote for the transform function. Maybe the way I told it out was not correct. You see what I mean? So the domain restriction happens only on the original function. So that translates to the range of the inverse trig function. Make sense, guys? And what is this principle? I want to explain to you what is this principal values. So if ever they ask about principal values of trig functions, right, you will say the answer only in the restricted domains. If they ask you for principal values, okay, suppose let's say, see, basically the sinusoidal graph repeats itself, right? So this is a huge it goes on and on, right? So the value here is the same as the value here. Basically, so there's a lot of repeats. When you think about the unit circle, right? When you think about unit circle, let's say sine graph itself. When you think about sine graph itself, the graph repeats several times. Here, x is negative minus root 2 by 2, root 2 by 2. Here it is, x is negative, y is negative, root 2 by 2, root 2 by 2, right? Here it is root 2 by 2 and then minus root 2 by 2, cos and sine, right? Each is cos and sine. So here, there is a negative value and there is a negative value here, right? So at two places the sign values are the same, correct? Similarly, this sign value is the same as this sign value. There are two places where the sign value is the same, correct? Here, when in inverse trig functions, sine inverse we have considered, right? So when they ask you for sine inverse of root 2 by 2. Suppose if they ask you, hey, find out what is sine inverse of root 2 by 2. Yes, there are two places in the unit circle where it is the same root 2 by 2. But then you will not, many a time, the question will say, find the principal value of sine inverse of root 2 by 2. That means what? They are literally asking you to find out the sine inverse of root 2 by 2 in the restricted domain. So which quadrant will be your answer? Which quadrant? See, there are two places where sine inverse of sine function value is root 2 by 2. But if they ask you to find the principal values, you will have to tell the value only in the quadrant that becomes a part of the restricted domain. So what value will you say? Will you talk about this quadrant or this quadrant? Am I making sense? Yeah, I want answers.
If
It's quadrant 1.
Quadrant with the negative.
Quadrant 1, because this is the principal quadrant, principal value quadrant for the sine function. Makes sense, guys? Why? Because this is pi by 2, this is minus pi by 2, and we have restricted the domain to minus pi by 2 to pi by 2. So the right side is always your sine inverse principal values. Make sense, guys? Does it make sense? Can I move on? Can I move on? Yes, ma.
Why is it always the right side again?
Because, okay. One second. Why is it always the right side? What restriction did you give to the original function? To make the inverse a valid function, what restriction did you give to the domain of the original function?
That has to be between -1.
Yeah, domain of the original function is always in theta. The value of theta should be between pi by 2, minus pi by 2 and pi by 2, correct?
Yeah.
So that's what you gave. You gave the restriction as, hey, my sine inverse graph my sine graph should all, meaning whenever I have inverses, for my inverse to be a function, my x value should be between minus pi by 2 and pi by 2, you said. In the unit circle, this is minus pi by 2, this is pi by 2, correct?
Yeah.
So this side minus pi by 2 to pi by 2 is where you are restricted the domain. The restricted domain falls from minus pi by 2 to pi by 2. So only this part of the graph is valid principal values for sine inverse.
Isn't that the restricted range?
Is it not, Emma, restricted range ma of the transformed function, but where are you restricting the domain? You're restricting the domain in the original function. You see, all reals was there, right? But when I change it, right, meaning I cannot have all reals as the domain in my inverse function. That is, see, this I have also got confused when I studied. When I first studied, I have also got confused. The domain you restrict it only on the original trig function, okay? And when it transforms to the inverse function, it looks like you are restricting the range. Make sense?
Yeah.
Yeah.
Okay. We always talk about domain restrictions. We don't talk about range restrictions. You see what I mean? So we always talk about where this all reals cannot happen in your inverse function. Then it will not be a function. So you restrict the domain from minus pi by 2 to pi by 2. Yes, I am writing the range here, but that is in the inverse trig function. Original function, the all reals you cannot have it. In the inverse function, you can plot only values that exists between minus pi by 2 to pi by 2. Can I move on?
Yes, Priya.
Yeah, ma'am?
Quick question. So, when you're restricting the domain for the original function, do you draw out the inverse function before you do that? To help you restrict the domain?
I don't understand your question, though I understand a little bit. What is it?
So, how would you know like where you restricted to? Like, do you draw out the inverse trig function to find out to where you restrict the domain?
Oh, okay. So initially, for the first time when you draw, right, this entire function, you know, as a student. One second. Where did my notes page go? Where did the graph go? Are you able to see the graph?
No.
Oh my God. What did I do? I don't know what I did. Hold on. Okay, let me take this. First time when I draw, right, ma? First time when I draw, I'm okay to do this. But after that first time, right, for you to understand, I drew the entire function. That's why I put it in a different color. Here you're having the entire function, right? So for me to get going for now, meaning for the first time, for you to understand, we went ahead and plotted like this, right, ma? Okay, but as you move on, right, principal values, how will the graph appear? Principal value graph is this. Got it?
Yeah.
Got it? You will never ever use this graph because it's not even a function. But I wanted to show you the difference between your origin. See, if you just invert it, directly map it x to y to x, this will be your graph. Correct? I don't want that. It won't work because it's not a function. So for me to restrict it, I'll always do. Tomorrow, if they ask you a transform sine inverse of, let's say, theta minus pi by 2, if they do this, then you will have to draw only this piece of the graph. You transform only that piece of the graph. Make sense?
Yeah. No, I was asking like, how would you know the restriction for the domain? Like, if do you draw the inverse to find out the restriction?
Yes, for the first time you draw the inverse. It's okay, okay. For sine inverse graph, the principal value is always minus pi by 2 to pi by 2.
Oh, okay.
Okay, but then for the cos, we'll see. Right away for the cos, we'll see. You'll understand. See, for the sine inverse function, it's always minus pi by 2 to pi by 2. Okay.
Miss Priya,
Uh-huh.
I have to go now.
Okay, ma. Go.
Okay, bye.
Bye. Yeah, we'll continue with our 15-minute more class as well. So that way I complete. Okay. Now, go ahead, Manav. So here, how about the cos and arc tan? How about this? How about this? We'll quickly do this. So here, what do you think is going to happen? Cos, I'll show you what is going to happen. Cos is, let me put it down. So pi by 2 is, let me put pi by 2, 0, minus pi by 2, x and y, right? X, y. So see what happens. Minus pi by 2 is a 0, right? 0, and then this is a 1, this is a 0. Let me go to a minus pi, it's a minus 1, pi, it's a plus 1, right? So when I invert it, right, what is going to happen? This is for this graph. For this graph, I just switch x and y, right? 0 is a minus pi by 2, then 1 is a 0, 0 is a pi by 2, 1 is a pi, and then minus 1 is a minus pi. Any questions still here? Any questions still here? Okay, so now minus 1 is a minus pi, right? It's not making sense. Hold on. Yeah, minus 1 is a minus pi. Okay, and then 0 is a minus pi by 2. 0 is a minus pi by 2, and then 1 is a 0 is a minus pi by 2, 1 is a 0, okay, and then what? 0 is a pi by 2, okay, and then 1 is a pi. 1 is a pi. Any questions, guys? Any questions?
No.
Okay, so minus pi, I'm just checking once more, guys. Minus 1, okay, that's correct, and 0 is a minus pi by 2, correct, and then 1 is a 0, 1 is a 0, 0 is a 0 is again a pi by 2, 0 is a pi by 2, and then 1 is a pi. 1 is a pi means here, right? What mistake I did? Oh, pi is a minus 1. I made a mistake here. Okay, pi is a minus 1, right? Pi is a minus 1. That is a mistake. Pi is a minus 1, so this one will change. Pi will be a minus 1. Pi will be a minus. Any questions? Pi will be a minus 1. Oh my god, I'm not able to write. Pi is a minus 1. Any questions, guys?
No.
This is the exact plot of the inverse function. But you know what? From next time we won't be doing this at all. So let me show you this nicely one time. Okay. Here when you think about it, so we'll go ahead and graph. See, this is what should have happened. But is this a function? Is this a function?
No.
No. So how am I going to restrict it? We have come to meaning for the cos, right? We are going to restrict from. I have to restrict the domain somehow, domain in the original function for me to make the inverse function a function. Right now, it's not even a function. So I'm going to consider only this part of the graph. So what is this part of the graph? What is that part of the graph, so that it's not getting repeated? So only this part of the graph I'm going to consider. So let me erase this and show you what part of the graph will be. Dhwani, you're following Dhwani?
Yeah.
Okay, so this part of the graph I'm going to use. You see? Make sense?
Yeah.
Only what? -1 to 1, so here. So it's going to be, wait. Did I
Miss
do it
Priya,
correctly? Yeah, ma?
so for like both of these, the inverse for cosine and sine, will it always be restricted, like the range to
Yeah,
graph
yes,
it?
yes, yes, yes,
Okay.
100%, yes.
Okay.
100% it'll be.
And is there inverses to the reciprocals?
In the reciprocals, no, you don't have to restrict the domain. You see, okay. For the inverses, right, ma? You're going to, for the inverses, you're going to have functions like this, right, ma? You see?
Yeah.
So there is no need to restrict the domain. It can continue till infinity and it will still exist as a function. You see what I mean? Meaning there is no way a vertical line test is going to fail. Do you understand what I mean, Dhwani?
Yeah.
So there is no restriction on the domain required. But in the inverse trig functions, the problem is when you invert the graph, when you find the inverse of the graph, right, they become non-function. They don't remain as functions. That's when you restrict the domain. Make sense?
Yeah.
So the restricted domain is what in here? 0 to pi. 0 to pi. For a cos function, it's 0 to pi. Restricted domain of the arc cos is 0 is less than or x is less than or equal to pi. Okay. Make sense? This is always -1 to 1. That is easy. Does it make sense? For a sine function, it's minus pi by 2 to pi by 2. So in a unit circle, think about it. Which are the principal values for the cos function? This. Principal values for the cos function occurs in the shaded area. Inverse of sine function occurs here. Make sense? This is sine inverse principal values. This is cos inverse principal values. Any questions? Advik, did you get it?
Yeah.
Now, for a tangent function, what happens? It's so funny. Tangent function is even funnier. Let me show you the graph. Tangent function, you have pi by 2 asymptotes, right? Pi by 2 is undefined in the graph, right? So here, pi by 2 becomes a horizontal asymptote. You see? Very funny, right? And then 0 is a 0. When you look at it, 0 is a 0, right? And then at pi by 2, it tends to infinity, minus infinity. See, at pi by 2, it tends to plus infinity, right? At minus pi by 2, what happens? It tends to minus infinity, correct? So see the graph is going to be like this, lying down. You got it? Dhwani, are you with me? Krish, are you with me? Lopa, are you with me?
Yeah.
Okay, so it's a little different, that's all. Here we had this. Okay, here we had this, right? Sorry guys. We had this, right? Wait. So for a tan inverse, it's going to be a lying down graph. For a cos inverse, it's going to be, I don't know, S hook just reflected is what I am thinking. I can say S hook reflected. So basically for a cos, it was like this, right? I don't know why I'm not drawing. Here, it was like this. Make sense? For a tan, it's going to be like this. You have to restrict the domain definitely for Sine we restricted it to minus pi by 2 to pi by 2. Cos we restricted it to 0 to pi. Tan, what will be the restriction? You tell me. Tan, what will be the original graph? If I plot, right, it's going to be like this for the original graph. So what will be the restriction? What will be the restriction for tan? Just one piece we need, right? We cannot have multiple of these because it will no longer be a function. What will be the restriction on tan? You guess. Guys, I want you to guess, guys. Make an educated guess. When will this become a function? We cannot have functions like this. See, vertical line test literally fails very badly.
Maybe like negative pi over 2 to pi over 2.
Correct. It's the same as sine. Negative pi by 2 to pi over 2. See, I'm restricting it to only this piece. So that
So
this all disappears.
Principal value for this? Or is
Yep,
there...
Same. You tell me. What is the principal value for this? Same as?
That, like the one that's drawn on.
Pi by 2, minus pi by 2 to pi by 2. You told, right? Minus pi by 2 to pi by 2, right? Same here. Same as sine inverse. Sine inverse and tan inverse, principal value area is the same. Okay. For cos inverse of x, the principal value is 0 to pi. From 0 to pi, right? So the principal values happen here. Make sense?
The principal values are like just a period long. Like
The principal values are not
like a period on the y-axis instead of the x-axis.
Okay, I take it. Yes and no. Dhwani, I see what you're saying. Yeah. But the period is not defined on the y-axis, right, ma? Okay, I get it. Yes.
Yeah.
Yeah, I hear you. Yes. But we don't tell it out like that. You see what I mean? Mathematically, what we tell is incorrect, right? Period on the y-axis. That's incorrect, right? But what you say is right. Does it make sense? Yeah, any questions still here? These graphs was the hard part, guys. So that's why I wanted to cover that today and make sure you understood what we are doing. Now let's see this one. Let's see one of this one. I really want to do one graph. I don't know. Okay, I really want to do this graph. Let's see. Let's see this graph. I'm going to find the inverse of this function and graph it. I'm going to find the inverse of this function and graph it. We'll finish with this, okay? That was a nice lesson today. Okay, we'll find the inverse of this function and graph it. What do I do here? You know how to find the inverses, right? Let me rewrite the function as 2 sine x plus 1, right? When you find the inverse, what do I do? Sine y plus 1. Now x minus 1 equal to 2 sine y. What do I do? Y, no. Sine y will be equal to x minus 1 by 2. Divide by 2 on both sides. This was subtract 1 on both sides. When I do that, y will be equal to sine inverse of x minus 1 by 2. I rewrite this function as y equal to sine inverse of you see 1 by 2 x minus 1. Make sense, guys? I'm going to graph it and show you. I don't want to use my own diagram. Wait. Because those diagrams don't come out well. Wait, I want a graph. I want a nice graph. Okay, I'll use this graph. Yep, I'll use this graph. Okay, let me use this graph. Let me plot it here down beneath, okay? How to plot this, guys? Who can guide me? Who can help me? How shall we plot this graph? You know, we restricted the domain to, what did we restrict it to? Remember, how was the sine inverse graph? Do you all remember how was the sine inverse graph? Okay, let me redraw. I'll show you the sine inverse graph. Sine inverse graph was just this, right? Now, how are we going to apply the transformation? You see, there was a horizontal dilation of 2. horizontal stretch of 2 means the x value of 1 got multiplied by 2. So that came here. Now this minus 1 got to minus 2. Any questions, guys?
Yeah.
Yama?
When you divide by sign, wouldn't it be like x minus 1 over 2 divided by sign? Or like you just multiply it?
Where, ma? Tell me step
You were
number.
solving for
Step.
y.
Huh?
The step 1, like when you divide by sign.
I didn't divide by sign, right, ma? Ah, okay, Dhwani, I got your question. You're asking about this, right?
Yeah.
I am not, okay. Amma, I'm not dividing here by sign. Like here, I'm taking sine inverse on both sides. It's like square rooting on both sides.
Okay, I understand.
Okay, so that's different. So when you take sine inverse on sine gets cancelled, y will be equal to sine inverse of x minus 1 by 2. Make sense? Okay, now how do I transform this function? Horizontal dilation of 2, I obeyed. Okay, this one value was changed to 1 times 2 minus 1 times minus 1 times 2, 2 minus 2. So I did that. But then there is also a horizontal shift of 1 to the right. So this came here, horizontal shift of 1 to the right. Now my graph will become this. Do you get it, guys? Do you get it? They're not going to give you very hard graphs, but then the basic ones you should know how to do. This is a horizontal dilation of 2. So you multiply all your x values by 2. Only 2 x values you're going to have. 1 is 1, 1 minus 1. So multiply by 2, 2 and minus 2 will be there. But then you should also account for the horizontal shift by 1. Does that make sense? But here, did you see? Yeah, see, they already restricted the domain. You see, the original function, they restricted the domain. So what will be, okay, they restricted the domain, right? So can I ask you this one question? What happens to the domain in the inverse function? What happens to the domain in the inverse function? See, here my inverse function, this is my inverse function. The range is going to be the same thing as the domain of the original function. This is so easy for me to write. Okay, but what will be the domain of the inverse function? What will be the domain of the inverse function? Tell me, guys. What will be the domain? Minus 1 to 3. Shragvi, are you with me?
Yeah.
Minus 1 to 3. Minus 1 to 3. Any questions? Okay, I can stop here, guys. We'll continue with those 3 easy functions next week, because that's easy compared to this. Okay, cot, cosecant, secant, I'll show you the graphs and we'll do some more graphing. Okay, there is something that I have missed. Sinusoidal function, word problems I didn't do. I did not do statistics, meaning data modeling using sinusoidal function. Those 2 are pending, which I just skimmed through. I did not do it with your class. I would really like to do that next week. Any questions for me? Any questions for me? See, more like we are only understanding the fundamentals. You will have to work on more in-depth problems for you to be good at all these. Please do the assignments, come back, ask questions. You see, it takes time to understand the fundamentals. Once you understand the fundamentals, you can build on it in school or by doing the homework. It's not like I'm doing so many problems. We are only going over the conceptual things pertaining to pre-calc. Any questions? Okay, guys, I'll let you go. See you all next week. Have a nice week ahead. Next week, we'll have a longer class as well.
Thank you.
Bye, guys.
Thank you, Auntie. Bye.
Bye, guys.
For the longer
Yes.
class, is it possible to start earlier?
I don't mind, Amma. I don't mind starting early at all. But I think indeed it's easier for me too. I'll put it out in the group in SEMA, but I doubt whether Shragvi all can make it.
Oh, okay.
I will try.
It's pretty late.
Yeah.
It's around like 9:40 if
Yeah, it's too late for you, you're thinking, right? Vani, I respect your priorities. I'll ask.
Yeah, or I can do both times. I just prefer if you
Yeah,
like did it.
I hear you. Okay, I'll put it out in the group. Otherwise, also, I'll ask for 15 minutes early, 15 minutes late. Make sense?
Yeah.
I'll do that. Yeah, I respect your whatever you need. Tell me. What else? You had some
Uh,
questions, right? Show me the
no,
question.
I think I understood it. Once I looked at it, I understood it. Like you were also explaining transformations a bit in the beginning. I
Uh-huh.
understood how to do them.
Okay, I'm glad you're patching up the gap. See, that's how the classes work. Great. Okay, ma. But so you don't have any questions?
No, not anymore.
Okay, good, ma. That's good. Okay. Yeah,
Yeah.
anytime ping me in WhatsApp as well. I'll help.
Okay. Bye, Miss
Okay,
Priya. Have a
bye,
nice
ma.
day.
Bye, bye.